Hello, my name is Todd. In this video, I'm going to introduce an environmental risk assessment management framework for climate change impact assessment. We will begin with introduction, including background, basis of framework and the impact threshold. Then we will analyze the framework. After that, we will draw a conclusion. Risk itself is defined by the U.S. Presidential, Congressional Commission on Risk Assessment and Risk Management as the probability that a substance or situation will produce harm under specified conditions. Risk is a combination of two factors. The probability that an adverse event will occur and the consequences of the adverse event. Risk is defined as the probability that environmental risk management or risk assessment is the process of identifying, evaluating, selecting, and implementing actions to reduce risk to human health and to ecosystems. The increasing importance of environmental quality to the economy, human health and ecosystems. However, the command and control regulation has failed to deliver adequate outcomes. The environment is directly exposed to risk from climate change. Environmental change resulting from climate change may threaten human activities. Many different methods have been applied to climate change impact assessments. We can identify that the previous framework is not perfect. A major limitation of impact assessments is the use of plausible climate scenarios with no information as to their likelihood. This limitation is due to the high uncertainty associated with projections of climate change in previous assessments of the IPCC. As a result, adaptation options typical of the second assessment report and the subsequent regional impacts report tends to be broad and generic. Thus, we come out with the following basis of framework. Key climatic variables forcing an exposure unit at a particular location can be identified and used as input for an impact model. Those variables can be expressed in terms of a projected range with high and low extremes with a given probability distribution function. An impact threshold forced by those key climatic variables can be quantified with reference to their projected ranges. A conditional probability of that threshold being exceeded can be calculated on the basis of explicitly referenced assumptions linking key climatic variables and an impact model. Adaptation and/or mitigation options can be assessed to reduce the exposure of that threshold to climate change. What is impact threshold? Impact threshold is any degree of change that can link the onset of a given critical biophysical or socioeconomic impact to a particular climate state or states. We should understand these keywords including any degree of change. Critical impact, a particular climate state. There are two main kinds of impact thresholds: biophysical thresholds that mark a physical discontinuity on a spatial or temporal scale, and behavioral thresholds where reaching a particular state triggers a change in behavior in the form of a social or economic outcome. Behavioral threshold can include change of legal, regulatory, economic or cultural behavior. Biophysical threshold can include distinct change in conditions, such as the drying of a wetland, floods, breeding events. In order to carry out risk assessment, there are mainly 7 steps. 1. Identify the key climatic variables affecting the exposure units being assessed. 2. Create scenarios and/or projected ranges for key climatic variables. 3. Carry out a sensitivity analysis to assess the relationship between climate change and impacts. 4. Identify the impact thresholds to be analyzed for risk with stakeholders. 5. Carry out risk analysis. 6. Evaluate risk and identify feedbacks likely to result in autonomous adaptations. 7. Consult with stakeholders, analyze proposed adaptations and recommend planned adaptation options. So, what's the role of stakeholders? Are they important to the risk assessment? Should they determine the thresholds? There are pros and cons. Allows the choice of a series of thresholds of varying degrees of change, and containing both positive and negative outcomes. However, Thresholds based on outcomes at the interface of physical and socio-economic systems can contain a great deal of complexity as well. Here comes the graph of framework. We have FCCC and IPCC on the top, stakeholders in the middle, circled by key climatic variables, scenarios, sensitivity analysis, impact thresholds, risk analysis, autonomous adaptations, planned adaptation. Step 1. Identify the key climatic variables affecting the exposure unit being assessed. For example, climate sensitivity can be nominated on the basis of experience, previous research, or may require new research where climate is known to be a strong driver but the exact mechanism remains unknown. Ideally, the key climatic variables should be explicitly dealt within the impact model to be used in risk analysis, or be readily represented by a dependent variable. Too little information at this stage will prohibit a numerical risk analysis, allowing risk to be assessed only in a general manner. Step 2. Create scenarios and/or projected ranges for key climatic variables. In this step, we can derive scenarios from models. With our data, we may apply uncertainty analysis. In some cases, Bayesian type analysis could be quite useful. But we should keep an eye on specific single event. Step 3. Carry out a sensitivity analysis. A guided sensitivity analysis is carried out by applying artificial scenarios of key climatic variables to an impact model using the likely ranges of climate model outputs as a guide. A numerical sensitivity analysis is carried out by applying arbitrary changes to the key climatic variables contributing to the impact models to be used in a risk analysis. The range of arbitrary changes applied should exceed the projected range for each key climatic variable. Many impact assessments that are driven by arbitrary, but plausible, changes to climate inputs can be considered little more than guided sensitivity analyses. Step 4. Identify impact thresholds. As we can imagine, it could be quite complex. For example, when studying species distribution, there are many factors. Climate prolonged shifts beyond current distribution. Quantitative change in core climatic distribution. Climatic thresholds acting distribution. Step 5. Carry out risk analysis. In this step our aim is to calculate the risk of exceedance of given impact thresholds. We should use the previous results, including impact thresholds in step 4. Projected ranges of uncertainty for those key climatic variables in step 2, and sensitivity analysis, in step 3. Step 6. Evaluate risk and identify feedbacks likely to result in autonomous adaptations. This step is identifying the likelihood that a critical threshold, or a lesser threshold identifying a degree of harm, may be exceeded opens a window for adaptation. What is autonomous adaptation? Autonomous adaptation occurs unconsciously in biological, social and economic systems where they adjust in response to a changing climate. For example, for irrigation demand under climate change, autonomous adaptations due to climate change include carbon dioxide fertilization effects, increasing pasture productivity, and changing commodity prices due to altered patterns of global agricultural productivity. In addition, land use and water quality may deteriorate faster due to the impact of climate on the widespread salinity problem already affecting the region. Adaptations to other ongoing processes include economic reform of the water industry, changing dynamics between input costs and commodity prices, changing technology, and the increasing globalization of agriculture. Even if these influences cannot be quantified due to high complexity or large uncertainties, autonomous adaptations should be identified. This will identify gaps in existing knowledge that can be assessed qualitatively. Step 7. Consult with stakeholders to analyze and recommend adaptation options. In this step, there are two questions concerning the results of a risk analysis. Is the level of risk sufficient to warrant treatment? What forms of planned adaptation are acceptable to stakeholders? In the real world, distinctions between planned and autonomous adaptations are rarely clear-cut. But there are a number of examples of planned adaptation where gradual changes have been imposed through treaty or legislation to meet a target. Some years into the future, and include the Kyoto Protocol, vehicle emissions in California, and the vehicle import tariff scheme in Australia. Fiercely, adaptation to climate change is unlikely to be implemented in isolation but integrated with adaptation to other drivers of change, such as economic change, greenhouse gas mitigation, sustainable use of resources, and cultural and political change. Secondly, there is a broad convergence of techniques under the subject of environmental risk assessment, management that forms a body of knowledge encompassing scientific, economic and social theory that is broadly applicable for use in climate change impact assessments. Although some of the terminology is different, many of the principles are the same. Thus, development of climate change adaptation assessments involves risk analysis, representation of stakeholders' interest. The risk assessment framework outlined in this paper offers a formal methodology for assessing the risk of climate change to individual exposure units identified as potentially vulnerable to climate change. This framework is consistent with other forms of environmental risk assessment management through its stakeholder focus, strong communication links between parties throughout the process, and a flexible framework for analysis that embeds scientific methods within a broad framework of social decision-making. However, we should adapt the framework wisely. At the same time, we should learn to fit in the cases in detail, as different cases have many different potential aspects. That's why we should use the framework wisely. What's more, in some situation, we should not only consider the change of climate. There might be many other related factors. The end. Thank you for watching this video.